Now that we've covered some best practices and tips, let's take a look at some of the settings controls that exist under the Fuzz Shader. If you look at the image to the right of the screen, you'll see a screenshot of the Fuzz Properties subtab within the material graph. Notice that there are quite a few different settings from length to maximum curves. Length, length variation, randomness, and segments are going to be your preliminary controls for creating realistic and varied fibers. Naturally, surface fibers tend to be random in direction and length, so adjusting these to mimic real-world geometry is the fastest and the most effective way of adding a higher level of realism to your fuzz applications. Depending on what you're after, this might take a little tweaking here and there, but once you're dialed in, the end results are pretty incredible. You can also control settings such as density and radius, which will help you better match real-world geometry. Adjusting radius and density can make the difference between creating a material that looks heavy and absorbent, such as towel fibers, or light and delicate, such as fuzz found on fruits or insects. The right side of the material graph is also where you'll find your appearance controls when the fuzz geometry node is selected. Here you'll be able to control color, roughness, transmission effects, and refractivity of your fuzz fibers. Take into account that if your base material or any other chosen material is plugged into your surface input on your fuzz geometry node, then your appearance options will appear grayed out and you will not be able to adjust the parameters under the appearance accordion. You can see that here, the input is selected, it's grayed out, you can't control anything there. All right, now that we've looked at using the basic fuzz node parameters to customize your fuzz applications, let's talk about controlling fibers using the texture inputs. If you look at the fuzz geometry node in the material graph, you'll notice that you have 3 texture controls relating to your fuzz application. The first of the 3 is density texture. The density texture allows you to add variation to the density of the fuzz fibers in your application by applying a texture map. When using a black and white texture map, in white areas, the density will match the value you entered in the density parameter, while darker areas will be more sparsely populated with fuzz fibers. In the example on this slide, the bottom plane shows the texture used to manipulate the fuzz density in the top plane. Notice that the highest density area is the area that is 100% white, with the texture losing density as it gradates into pure black. The second node is length textures, where length variation parameter adds a randomness to the length of the fuzz fibers. The length texture enables you to manipulate the length based on a texture map. This will act as a mask to the length while still taking into account your length variation settings. 100% white will result in the length defined under your parameter settings, while darker colors will produce progressively shorter fibers. In this slide's example, you can see a black and white texture map below, which is affecting the overall distribution and patterning of the fuzz effect on the plane above. Take note that the length texture reacts similarly to the density texture example. Areas that are pure white are unaffected, while darker areas exhibit a reduction in fuzz length. Lastly, under the texture controls, we have the direction texture. By default, the fuzz fibers will follow the geometry's normals. Adding a direction texture will enable you to manipulate the direction at which fuzz fibers protrude from the surface. You can use either a normal map or a procedural texture to do this. The bump height of the direction texture controls how much the direction is altered. At a bump height of 0, fibers will follow the normals. Increasing the value will increase the angle at which fibers protrude, while negative values will angle the fibers in the opposite direction. In this example, a normal map is used to manipulate the direction. The bottom plane shows the texture used to manipulate the fuzz direction in the top plane. The first image example, the bump height on that texture map is 1, while it is -1 in the second image.